Hey everyone, my name is Bo. Thank you so much for joining today. We are really excited to bring you this presentation from the VM Zinc team on the zinc building envelope, the sustainable architectural metal of choice. I'm going to give a quick background about myself and about Acelab. That's the company that I work for. We are helping to host this event. Show you a quick demo of our website, and then we can go ahead and get started with today's presentation. All right, so this is a quick snapshot of our team. We're a team of architects building products for architects. My personal background, I got my master's in architecture from Tulane in New Orleans, worked there in some commercial and residential projects for a few years, and then moved to Brooklyn, where I worked at OMA and other high-end residential firms. And then I moved to Denver, where I live now, and joined Acelab as a product specialist. So at Acelab, I work with architects to help them use our platform to aid in their product research and specification workflows. So basically, we started Acelab because a lot of us had experienced something like this in practice ourselves. You know, anytime we were looking to do product research, find a product we had used in the past, often our processes felt really disjointed, and it felt like there wasn't really great places to, share our data and store our data. So Acelab has a really great library dashboard that we recently released. And that's really what I want to focus on showing you guys today, is this new way to kind of save and store your data on Acelab. So if you make an account and sign in, anytime you sign in, you will come back to this library dashboard. You're able to kind of see an overview of any of the research and work that you've done on Acelab. So we have a database of over 19,000 building products that you can search through, and really great visual search tools. You can save those searches to be able to really easily pick up where you left off. You can also save products. You can also have conversations directly through the platform. And we have a project portal. So your product library can be integrated with your project information. And just to quickly show you, so all of those buckets are over here on this My Library tab. Just to quickly hover over your project portal. So as you can see, I've uploaded a few projects here, and I've also named two of my projects General Research and Firm Standards. So this platform is super customizable. You can really use it to fit your firm's needs. And this just works as a great way to, save products throughout the site as you're discovering things and tag them with the information that you want to know for later. Uploading a project is really simple. We just ask for 4 questions. So it's really easy to onboard as many projects as you'd like. And then you can come back and add additional information anytime. You'll be able to save products, searches, and conversations all under your projects. And then to show you, you can see here, some of these are tagged with the different places that I've saved them. So if I've saved a product to multiple categories, I'll always have that information readily available. And you can also hover over to get an overview of all of the products that you've saved, regardless of what project they're in. They'll all be tagged here with their project location and filterable by product category. Quickly show you the searches tab as well. This is that overview of searches. So any searches you've saved to any product, you can also name them. So if you were looking, specifically into low VOC products and you wanted to kind of name that research, you can do that and be able to really easily pick up where you left off. And then the conversations is really exciting. So we are rolling out the ability to be able to communicate directly with product experts through our site. And if you communicate with a product expert about a specific project, that project information will always be saved here in the chat. So a lot less repeating yourself over the phone to multiple reps. You can really easily collaborate with your project portal here. All right, so that is it for my demo of Acelab. Thank y'all for watching that. If you are interested in learning more about how to use Acelab for your product research workflows, want to hear a bit more about some of the new updates that we have been releasing and are getting ready to release, I'm going to share a poll. And if you would like a free personal demo with someone from Acelab's team, you can feel free to say yes to this poll, and we'll reach out to you to schedule that call. and talk about how you can start using our tools for your workflows. All right, so I'll just leave this up for a few moments, but that is it for me for now, and I'm really excited to be able to hand it over in a moment to Milton Greenstein. So Milton is a product expert from Zinc, and they are here sharing this AIA-approved presentation with us today. All right, looks like we've had a good amount of folks answer, so I'm gonna just give it a few more moments. I will stop sharing my screen. And Milton, you can go ahead and start sharing yours. Oh, one last thing. I also wanted to mention we will have a Q&A. We'll leave a few moments at the end, but we have some extra folks from Zinc's team on the call today, so they'll be able to answer questions during the presentation. Feel free to enter anything in the chat, and someone will do their best to answer you right away. And if we don't get to your question, we will also follow up with you after the event. All right. That's it for me now, Milton. Take it away.
Okay. Are we good to go, Bo? Can you see my screen now?
I can see your screen. Looks like we're good to go.
Excellent. Well, thank you very much, Bo, for that gracious intro. And thank you to Acelab for hosting. As Bo mentioned, my name is Milton Greenstein. I'm joining you from Toronto, Canada today, and I am the Zinc sales manager for this country. And I am proud and honored to be presenting you today. I happen to work for the oldest manufacturer of architectural zinc in the world, Zinc. And topics that I'd like to cover today is the history of architectural zinc, some characteristics of zinc, building envelope assemblies, performance, compatibilities, and last but not least, sustainability. So a quick little intro in terms of Zinc. Like I said, the oldest manufacturer worldwide. There are some other manufacturers, but truth be told, it is truthfully only a handful, and making us essentially a niche market. So we're talking about a material that is extremely long life and very, very low maintenance. Those are two major key benefits to zinc in general. One common misconception that I like to address right off the bat is the idea that zinc is very expensive. When you compare it with other, other raw metals and other building materials, you'll find out that because of the long life cycle of zinc, it's actually not true. Another thing that is extremely noticeable, it was noticeable for me, is that I keep an eye on the commodity markets, and over the course of the last few years, the pandemic included, there was little volatility with zinc, where there was a lot of fluctuation with other common building materials, and specifically in other natural metals. On that note, I'm going to continue on with our slides. I've got a bunch to go through, and going to hop right into it here. So basically what we're going to be speaking about today is the usage of zinc as a building envelope. We're going to talk about zinc and our company, Zinc, but mainly we're going to touch on a lot of the common benefits of zinc in general. I'm going to describe some of the photos that we're looking at here, and they may be relevant to some of you viewing this webinar based on where you're located. But from left to right, I'll always describe photos from left to right. We're looking at the Samuel Rogers Health Center in Kansas City, the Gemma Observatory in Southern New Hampshire, Domino's Sugar Factory in New York City is actually the bottom right, and University of Alabama Huntsville Student Service Building is the last one. Now, I always start the presentation, you probably noticed from my opening page, when I'm in person, I ask I asked my audience to take a guess at what they're looking at, but since we are on a webinar here, I'll use it rhetorically. But essentially, what we are looking at here is an aerial shot of Paris with the Arc de Triomphe situated in the center. And what you're seeing is a whole lot of gray. And the reason for that is because most of the roofs in Paris are covered with zinc. And zinc naturally patinas to gray, just like copper turns green, zinc turns gray. In fact, 95% of all metal used in Paris for roofing is zinc. So that is why you're looking at this photo and seeing such pronounced gray. So in terms of installing zinc, it's been installed since the late 1800s, although our firm, VM Zinc, has been around since 1837. And the distinctive gray patina continues to cover all the rooftops, some of which are 100 years old, if not more. And I've been lucky enough to see a lot of these in person. And yes, they're definitely 100 years plus. I've seen roofs at VM Zinc factories that are 130 years old and have never leaked. You may have noticed that the tagline to hopefully entice you to joining this webinar, but we're going back into a little bit of history and speaking of a Baron named Haussmann, who actually combined with Napoleon made it so that the roofs in Paris became VM Zinc roofs. Now, as you can see in the photo, there are always slopes to zinc roofs, a minimum slope of 3 degrees, still a minimum slope for today. Although we like to look at projects on an individual basis. If you have a lower slope, we're happy to look at that and decide whether it's feasible or not. But when you go too low, it increases the chance of water ingress and staining. Essentially, what you don't want with zinc is any pooling or standing of water, because that will essentially eat away at the zinc, at its integrity. As long as you have slope, you are golden. Zinc is a natural element found in the Earth's core. Relatively common, in fact, and the richest areas of zinc are Peru and the country where I'm speaking to you from today, Canada. Zinc mines also do exist closer to France, where the manufacturing takes place, also located in North Africa, Sweden, and up until 1949 in the North Pennies. And if we're going back even further into history, traces of zinc were found in the ruins of Pompeii. So if you want to look at the longevity and how long zinc has been used, the ruins of Pompeii is a good indication of that. As I mentioned earlier, VM Zinc has produced continuously since 1837. We are proudly looking forward to our 200th year in business, which will be in the not too distant future. One important thing to note is in the 1970s, up until the 1970s, all zinc that was used architecturally was natural zinc. Natural zinc, you could look at and think, wow, that looks a lot like aluminum. But what happens very quickly with our zinc is it quickly develops a patina. Now, the original zinc that was used back prior to the 1970s had some impurities, such as cadmium, which is no longer used in any zinc worldwide. And yes, in fact, cadmium has been eliminated from zinc production for almost 50 years. Zinc production and sustainability. Now, zinc is essentially pure. Now we're talking 99.995%. And the reason why it isn't 100% is that there needs to be a small injection of titanium and copper that improves the tensile strengths of this material. Otherwise, it would just be too soft. That said, zinc is malleable, makes it very adaptable for all different types of architectural solutions. So basically what happens is from the extraction of zinc and that tensile strength being added via the copper and the titanium, it's then hot rolled and then rolled down to the necessary thickness. For North America, we use between 0.7, actually 0.5, but commonly 0.7 and up to 1.5 millimeters. Roof applications generally call for 0.7 millimeter, and walls range from 0.8 millimeter to 1.5 millimeter, depending on the profiles. 0.5 millimeter, as I quickly mentioned, is used for our composite material. Important to note, zinc is a non-toxic element. Another misconception is that leaching is dangerous, and there isn't a whole lot of truth to that. It's required by all living organisms, and again, it's an essential element. Another positive as it relates to sustainability is due to electrolysis taking place at room temperature, less energy is required to produce zinc than other metals as described in this graph. Again, we're looking at a material that once installed correctly is, 100-year material, and important again to mention that it's 100% recyclable. Here's a good example of the longevity of zinc. This is the Liverpool Central Library, a soft spot for me. Liverpool is my favorite football club. I follow them religiously, so I always love talking about this photo. This roof was actually replaced after 133 years. Some of the panels were starting to degrade and required replacement. However, the original sheathing, the open gap boarding was still good. So there was a good design originally and good installation, and that is really the key to zinc lasting, because the material itself can hold up to the elements, but it's the installation and the know-how that really is the difference maker. The corrosion rate currently are less than 2 microns per year. And if you wanted to do the math, a sheet of zinc is at least 700 microns thick. The aesthetics of zinc is what we're going to speak about next. Surface finishes. So what you're looking at here is our standard range of surface finishes, and they do vary from company to company. However, this is the VM Zinc range of standard finishes. The first picture is a patinated natural zinc. So you're basically seeing the forming of the patina that leads into the next color surface option, which is quartz zinc, which is the most popular internationally because it mimics the natural pigmentation of zinc. So essentially that natural zinc that you're seeing on the top left will eventually become uniform and look like quartz zinc. Following that, we have a pigmented range of colors: pigmento blue, green, anthrazine, which was introduced in 1978 to complement slate, is the dark, almost black option. Azengar is the first engraved zinc worldwide. Pigmento brown and pigmento red. Again, these are standard the standard color options. I forgot about the pigmento gray on the far right. As I mentioned earlier, natural zinc was the only option until 1978, and is initially shiny. And patinas, once it's in contact with H2O and CO2. As a rule of thumb, after 3 to 10 years, an even middle gray patina, similar to our quartz, is formed, but it takes time for this to become uniform, and many building owners, particularly in North America, are not that patient. Therefore, the quartz or the pre-patinaed, the pre-weathered zinc is the more common choice in North America. On the screen here, you're looking at, in the top left, a bar in the Montreal airport, my hometown. Top right, 2 pictures are actually unnamed projects. The bottom 2 pictures are the lead library at UNLV. So light gray pre-weathered zinc is what we refer to as quartz at VM Zinc. And again, it imitates the naturally weathered zinc in a pre-patinaed finish. On the left, you're looking at Jabs Hall at Montana State University, and the right is a private residence in New Orleans. Some more images. I know I love images. I hope you do too. The left is the Cleveland School of Arts in Cleveland, Ohio. And on the right is the University of Cincinnati Medical Science Building. I alluded to it earlier, but the dark gray zinc, which is almost a black zinc, was first created in 1978 to complement slate roofs as a flashing and gutter material. Since then, it has grown to be used for roofing and facade as well. Now, zinc would never naturally patina to this color, so this is a pre-patinaed finish. This doesn't happen naturally. Picture-wise, on the left, you're seeing the Ansley Glass House in Atlanta, Georgia, and on the right, the Porterhouse addition in New York City. Some more images and examples of anthrazinc. On the left is the 8th and 8th project in Calgary, Alberta, Canada. The middle top is the Leo A. Daly building, middle bottom Lone Star College in Texas, and on the right is the Herman Miller office in Georgia. Red, blue, green, and brown were the first standards in the pigmented offer in the VM Zinc world called pigmento. Now, very important to describe that the pigmented range is not a painted finish. That's what makes VM Zinc rather unique here. It's actually a surface color that's created by adding natural mineral pigments and along with a durable protective coating, which creates a beautiful organic finish. Now, all the pigmented ranges can be used as as the zinc and any other colors in zinc. They can use for all the applications that you could dream up, essentially. For roofing, in fact, we like to speak about the fact that we would prefer an extra coating to preserve the longevity of the color. But on facades, we don't deal with the same rigorous treatment. Picture-wise, we're looking here at on the left, Marchetto Architects in Hoboken, New Jersey. Middle top, the Spectator Hotel in Charleston, South Carolina. Middle bottom is the John Cooper School in Texas. And on the right, the Seattle Children's Hospital. Now, the color ranges in zinc are not limited. In fact, in the VM Zinc world, it's called the bespoke offer. So you can essentially choose different colors and if need be, create any color that you could possibly dream up with an RAL or a Pantone. Now there are some minimums in terms of ordering this. It's generally 3 tons, but if you do have projects that require a specific Pantone or a color, such examples of that could be at a university to match the university colors or whatnot, please feel free to reach out to us, and we could definitely look at that. Now, what is interesting to note as well is that all the colors here that you're looking at, or any color again that you'd like to match, the base color is our quartz, is the gray. So that's how we essentially we coat on top of the gray, and that is the way that we've noticed through testing that it works best. Engraved zinc, I mentioned it earlier. This is called a Zengar, and it's the first engraved zinc in the world. Again, it can be used for all applications, and it's one out of VM Zinc's newest properties. Left, you're looking at the office in Osaka, Japan, and all other pictures are residences in France. As you can see from this graph, VM Zinc is always innovating. From our inception in 1837 up until today, we are constantly looking at ways to improve our material, add new colors, add new options, improve what you can do with zinc. Roofing systems, what we'll speak about next. Standing seam is the most popular system worldwide, and it's flexible, so you can adapt to different roof shapes. On the left, you'll see the Ballstone Quarters Pedestrian Bridge in Philadelphia, and on the right, the Samuel Rogers Health Center in Kansas City. Left, you're looking at the Howard University in Washington. You can see that nice curved roof. And the dormers illustrate the flexibility of zinc. The left bottom is the James Madison Montpelier Visitor Center, in Virginia, and the right is the Brother Martin Chapel in New Orleans. Some of the more complex roof shapes, which are achievable with zinc, are illustrated here. The maximum length for a standing seam roofing panel is 30 foot. This is due to the thermal expansion of zinc, which is 1 inch for every 30 feet. The other reason for this limitation is for transportation reasons, as flatbeds generally can't hold much longer than that. Now, if there needs to be sections that require longer panels, that can be roll formed on site, and that would avoid those transportation limitations. Very important to point out that the traditional standing seam is not an industrial looking seam. In fact, when these panels are created either by hand or by machine, the seam is locked. Either for walls, you're looking at a single fold and a double fold for roofs, and they're locked manually. As you can see here, demonstrated by this tool. Here's a range of tools and some of the equipment options that zinc installers use. Here's a rolling machine that will form the standing seam panels. But again, they will be folded by hand on site once installed. Standard panel widths are recommended to maximize coil width and reduce material waste. So as you can see here, for roofs, we're looking at 0.7 thickness, and walls generally you're looking at 0.8 for the most part, up into 1.5. Now, in terms of concern for reducing material waste, that is the reason for the panel widths and the coil widths that we've chosen. However, if you need to design something custom, it's possible. However, you should budget for a higher cost for material waste. Now, here's the key when we're talking about installation, particularly for zinc with that thermal movement. Panels are fixed with fixed clips at the top and then sliding clips towards the eaves that allow for the thermal movement. Fixed area can vary in location depending on the slope. Low slope will mean the fixed area will be in the middle of the panel and the high slope at the ridge. Again, the minimum slope of 3/12. Now, this is an older photo looking at here, but it's important to look at the protective film, which does have arrows on it. Additionally, the protective film should be left on as long as possible to avoid incompatibilities with other surrounding materials or any sort of construction, such as cutting of limestone that takes place that may affect the zinc surface. Some of these slides are pretty self-explanatory. Now, flashings are important. The right details must be used. This is an example of a flashing that VM Zinc manufactures. It's called the G3 ridge. It's used for low profiles. Preform systems. This is an example here of the ADECA panel, which is very popular in Europe, and we are seeing the popularity here on the rise. As you can see, it's adaptable to curves and has a very beautiful aesthetic. Now, you need a slightly steeper slope for this to be feasible. These panels are 15.5 by 15.5 inch, and you need a 4/12 slope. Next to speak about is buildups. For roofing, the cold roof is the most popular system used. Now, on these next couple of slides, I will touch on some of the basics, but I'm lucky to have my colleague in the chat, Alex Pittman, who was the VM Zinc technical manager for North America, with a plethora of experience. And if you do have any questions, you have any technical questions throughout the remainder of the presentation, please feel free to reach out in the chat, and Alex hopefully will be able to answer those questions. Some of the details here in the cold roof, I'll let the slide speak for itself, but this is essentially the common buildup. Other option is the open gap timber boarding. And as we move to warm roofs, which are not popular in North America. In fact, I think, if I'm not mistaken, we've only had 2 or 3 come up in 2022. The reason being is that there was specific R values that needed to be achieved, and warm roof was looked at, although there are various other options with cold roofs that you can achieve the R values required. So we did look at a bunch of these projects, but determined that the cold roof actually was more feasible. Now, the importance of a properly designed buildup is almost self-explanatory, and as these images show, what can happen is a bunch of things, but backside corrosion is one of the things that may happen if not installed correctly. And it's important to point out as well that the buildup is naturally not just a zinc problem. This would be relevant for any metal roofing and siding material. So generally, we're talking about 2 methods skip sheathing is the oldest, using pine boards beneath the zinc roofing to, basically space them and compensate on the backside so that the water can dry and dissipate via airflow. There also is a newer approach that we're using for roofing that requires a drainage mat. Currently, VM Zinc is looking at a new solution. So there will be in the near future different options to look at for the underside of roofing elements. Facade systems. Now, what I always like to say is, well, we used to, in the older days, as you noticed in previous photos, we concentrated primarily on roofs, but simple math dictates that there's 4 walls and there's 1 roof. So although there could be different elevations for roof, but essentially there's a lot more coverage that can be achieved on buildings with zinc. So we have started concentrating more so on the facades of buildings, although we still have that zinc roofing knowledge in our back pocket. Build up for standing seam cladding. This has an underside coating. It just demonstrates here that the fixing clips, the 5/8 minimum plywood sheeting behind, approved slip sheet, the battens that create a vented 1.5 inch airspace, and some insulation protected by a breathable membrane. Standing seam panels will never be completely flat. However, using 0.8 millimeter thick and single lock panels, 430 millimeters wide will definitely help with this. For installation ease, it is recommended that panels be no more than 4 meters in length. Now we are seeing more and more requests for non-combustible systems, and this is an example here of a non-combustible steel deck option. Again, any technical questions, Alex Pittman is available in the chat, and you should be able to help you out. In terms of vertical standing seam cladding, there's lots of options. Again, due to the malleability of zinc, panels can be vertical at an angle or horizontal. On the left, you're looking at the Petty School in Hightstown, New Jersey. On the right, you're looking at the North Carolina AIA building in Raleigh, North Carolina. Along with panel variable orientation, various window flashings and corner details are possible. On the left is the BMW iCar building in Greenville, South Carolina. On the right is the University of Cincinnati, Tangeman Hall in Cincinnati. Diagonal standing seam. On the left is the Abbeywood Cross Rail Station, and on the right is, believe it or not, a school. I'm guessing an art school. It's called the Pimlico School. Zinc used for renovations. This is the Parsons Tower project in Newcastle, England, where a dark and light gray pre-weathered zinc were used to renovate an old 1960s block. So zinc lends itself well to this use and is lightweight, flexible, and obviously a dry trade. Flat lock cladding is another option. Flat lock panels exist in all shapes and sizes. And again, the buildup here shows the fixing cleat, a fixing strip, 5/8 plywood again, battens creating the 1.5 inch airspace, and again, the insulation protected by a breathable weather membrane. For rectangular panels, maximum size is 16 inches by 9 foot. On the left, you're looking at the Cloudwall, Missouri, University of Cincinnati, Swift Student Life Center in Cincinnati. On the left is the Johnson County Crime Lab in Kansas City and the University Town Center in Maryland. Oh, the 8th and 8th project in Calgary, Alberta, Canada is getting another bit of shine here on the left, and the Fayetteville State University in South Carolina is on the right. Preform systems, we touched on this a little bit earlier. In the VM Zinc world, these are called Adeka. This is an example here of a Whole Foods market in Buckhead, Georgia. Very easy to install and can be curved naturally on site in the field. Overlapping panels or shiplap panels is another option. Not very popular in North America, I think because they're, I guess, rather basic and mimic a common vinyl siding. And if you're going with a premium material like a zinc, I think generally the choice is for something a little bit more complex and also maybe going for an aesthetic that is more regal. Some more images here of our siding or the shiplap panels. Interlocking panels. Now we see these everywhere, particularly in institutional work, and have probably become the most commonly used rain screen panels in zinc. The panels have a depth of 1 inch and joint widths are typically 1/4 inch, 1/2 inch, and 3/4 inches. As you can see on the slide, it's a breakdown of the buildup. Pictured here is the Leesville Library in Raleigh, North Carolina. And the right top is the LA Tech Lambright Sports and Wellness Center in LA. The right bottom is the Greensboro Transportation Authority in Greensboro, North Carolina. There's a private residence, interesting design there on the left, and Campbell University in North Carolina on the right. Sine wave or corrugated panels are available in all finishes. Standard size is 32 7/8 inch by 120 inches or 10 feet. And these are this is one of the few systems that actually has visible fasteners. Stainless steel screws are what fasten these panels. Pictured here is the NSCAD University in Halifax, Nova Scotia, Canada, which uses corrugated as well as perforated panels that you'll see here. So perforations are an option with 51% opening, depending on the hole size. Some more visuals of corrugated here. Cassette cladding is what I'd like to speak about next. So these are for panels that are up to 600 millimeters wide. And this would make for a good option if you need something that is very flat. Dry Design is one of the companies commonly making these cassettes. And maximal panel size is 600 millimeters by 2400 millimeters. And they can be installed either horizontally or vertically. Panels can be produced up to 900 millimeters wide, but they will be less flat and resistant to wind loading. Now, as you can see on the image on the left, the panel depths can be different, which creates a very unique aesthetic. On the right, you're looking at a private house in Cincinnati. Composite cladding. As I alluded to at the beginning of the presentation, VM Zinc composite consists of 2 layers of 0.5 millimeter thick zinc with a 4 millimeter fire-rated polyethylene core. Very important to note that it is fire-rated. And if you want something that has to be flat, this is your best option. Otherwise, the natural nature of zinc is there will be some movement. So you're not going to get a perfectly flat panel, Personally speaking, I like that aesthetic, but it really depends on the project. So zinc composite sheets are routed and then folded into cassettes. Then the panels can thus be cut, allowing different shapes to be formed, as you can see in the images here on the top left and right. That's located at the Brown University, and another university project is the Northeastern University in Boston, Massachusetts, which is the bottom left. Panel flatness. So essentially, the right system must be chosen to meet aesthetic expectations, as well as the correct thickness. So you want to, if this was described to you as a design intent, that you want something relatively flat, the correct thickness is essential to avoid that wavy effect. So if it's a project that needs to be absolutely flat, a composite or cassette panels would be the way to go. I want to touch now on some other systems. And firstly, the custom finishes that are available for zinc. This project here on the left is actually the Milwaukee Bucks Arena. And the coating, a third-party company, they applied a solution to our zinc in order to achieve this unique finish, also to, in a lot of cases, match surroundings. These images here are both the UAB Institute for the Visual Arts in Birmingham, Alabama. Here's an example of some custom finishes on the interior, and this is the Oak Leaf Restaurant in Pittsboro, North Carolina. This is actually the Stonehenge Visitor Centers in England. And as you can see, you're looking at a combination of perforated cassettes, and the edges, as you can see there in the picture on the right, are perforated with a custom design. Other options and uses, they can be used for a sunscreen that can be clad in zinc. This is a picture of the Nighthawk Museum, or sorry, the Nighthawk Cinema, pardon me, located in New York City, which I've seen in person, and it's very, very impressive at night. It is backlit, perforated panels that are backlit, and again is quite impressive at night. Rainwater goods is another option in zinc. And they've basically been around since the beginnings of VM zinc. And what's nice to note here is that a range of half-round gutters, as you're looking at here, in dark and light gray, so the Anthra and zinc, or quartz zinc, pardon me, are here in North America, stocked in both the US and Canada. Hidden box gutters can be put onto zinc roofs. Now, in some cases, stainless steel may be a better option for an in-box gutter, particularly if the gutter is not visible. And again, that reasoning is we don't want water pooling on zinc. Standing water on zinc is a no-no, whereas with stainless steel, you don't have those types of issues. Solar panels and snow guards are both options that can go right onto, in this picture is showing how it can be attached to a standing seam roof. And as you can see, it does not penetrate the seam. In fact, the clips, what's shown here is manufactured called the S5. and it pinches the seams, both on the solar panel and with the snow guards as well. Important not to overload the panels. Zinc for ornamental use. So essentially, zinc has been used as a material to create roof ornaments for almost 200 years. And here are some beautiful examples of that. I always like to point out that VM zinc holds onto these molds, and we have zinc molds that are over 100 years old, and if they ever need to be duplicated, we've still got the mold, so that's an option. More examples here of some ornaments. Back to perforated zinc and some images of this. The Poetry Foundation in Chicago is on the left, Cirrus Logic in Austin, Texas, public housing in Spain, it's a parking garage, and adjustable forms in Illinois. More examples here of ornamental use. Stamped zinc is an option, again, because its malleability, embossing and stamping is a feasible option. And spoke about interiors previously. Here's again some more examples of that. Exterior doors is another option. Essentially, the sky's the limit due to the malleability of this metal. Performance. We have achieved multiple performance credits, some of them noted here, some of them not noted here, as well as testing. So if a certain ASTM testing requirement is needed, please feel free to reach out to us and we can make sure that's met. In terms of coastal environments, zinc has been used on coastal projects for many years. However, we like to look closely at these projects, particularly if a dark patina is chosen, as there may be some salt staining, and this is not exclusive to zinc, or there may be some salt staining that will be evident just due to the environment of the project. So these projects we like to look at on a one-on-one basis. Compatibility is something that I like to talk about often with architects because in terms of zinc, there is an order of things. And basically the way it works is you want zinc above a lot of the incompatible materials. As long as there's no runoff from an incompatible material onto zinc, you're golden. So there are incompatible metals as well as high pH woods. We did a Hurricane Katrina case study, which turned out very positive for zinc. As you can see from these photos, that there was minimal damage to the zinc, whereas a single ply roof was basically torn off, and the winds in New Orleans basically reached up to 170 miles per hour. So that was a crazy storm, and we were happy to see that zinc was intact. VM zinc training, I alluded to this earlier. I can't say it enough. It is of the utmost importance because if you don't know what you're doing with zinc, you're bound to make mistakes. These courses are offered both in the US and in Canada. Some of the things you'll learn is the orientation of the metal. As you can see, there is a grain. Often you'll want to follow, in most cases you want to follow the grain, but there are examples of projects where you'd want to adjust the grain to create a unique aesthetic. Last but not least, a couple of beautiful projects. No bias here, but they're in Canada. This is the Barrett Center here at the Humber College in Toronto, also known as the Technological Blade. This is an interlocking panel project. And lastly, a project in Edmonton, Alberta, which was one of the first projects using a Zengar, the custom, the first engraved zinc on the market internationally. Essentially, that takes me to the end of my presentation, and I hope this was useful for all. Yes, I think we're going to open it up to questions, and I'll leave it up to Bo to take it from here. Thank you all.
So great. Thank you so much, Milton. Really informative and really great to see so many beautiful case studies. As some folks might see, I have put up a poll for the end of our presentation. If you can answer some of those questions, that's really great feedback for us. There's also a question at the end there. If you'd like to receive free VM Zinc product samples, you can go ahead and answer yes to that. I also want to mention that we will have a post-event survey where if you have any questions, comments, concerns, you forgot to sign up for samples or a demo, or you'd like to get in touch with someone, that's a great place to let us know that feedback. And then while we have a few moments left, I know that we've had quite a few questions in the Q&A, and Alex has been busy answering a lot of them. But if there are any that we wanted to briefly talk about out loud, we can do that while folks finish up that poll. So let's see. Okay, well, this one I'll answer about the CEUs. So for the AIA credits, if you are AIA, we will report those credits directly ourselves, so you don't have to do anything there. If you gave us your AIA number in the registration, then you are set and good to go. If you forgot to give us your AIA number in the registration, again, the post-event survey is a great place to let us know that information. You can also email me directly. My email is bo@acelabusa.com. That info will also be on the post-event survey email as well. And then if you are not AIA and you'd like to just get a PDF certificate for whatever other continuing education purposes you have, you can, again, feel free to shoot me an email or indicate that on the post-event survey. All right. Cool. And it looks like the rest of the requests from the Q&A are about some information and materials. So I'll let the VM Zinc team follow up with those either on the chat now or post-event after this. But I just want to say thank you to all of our panelists, to Milton, to the whole VM Zinc team, Alex for answering all those questions, and to everyone in the audience who attended today. We really appreciate it. Acelab will have another AIA-approved event next week on the 24th, so stay tuned for that. And if you don't already follow us on LinkedIn, that's a great place to get up to date with all of our events. We'll always post links to register over there. All right. So I think we've got about 1 moment left, and I know we've got a few questions still unanswered. If any of your questions went unanswered, don't worry about that. We'll follow up with you post today's event.
I'd just like to add, Bo, I truly hope that this does increase the confidence in the people that viewed this webinar in specifying zinc. Mm-hmm. There was a lot of information thrown at you, and if you're not familiar with zinc, it's a lot to take in and understand. But I truly hope that the confidence level has grown to get more familiar with this material, which is, in my honest opinion, the best building envelope material in the world.
Great. Thank you so much for that, Milton.
Thanks.
All right. I'm going to go ahead and end this poll. Looks like we had quite a few folks answer, and it looks like quite a few folks did answer that they do feel more confident specifying these materials. So that's awesome.
Oh, that's great.
Cool. All right. Thank you, everyone, so much. Have a great rest of your Wednesday, and we hope to see you next week at our next event.